All right, welcome to lesson 37, derivatives and derivatives of exponential and logarithmic functions. So what's the goal today? I can determine the derivative of an exponential or logarithmic function. So I don't need to be able to identify them because if you should be able to identify exponential and logarithmic functions by sight. So now it's just being able to actually determine the derivative of each. So from last day or from yesterday, note that the derivative of the natural base is itself. Now, as a note here, a side note, what happens if the exponent is not just x? So what happens if f of x equals e to the 2x, for example? The derivative would be, using chain rule, derivative of the function. So the derivative of an e function is itself. So now I've really taken the derivative of the function. And now you take the derivative of the exponent, and the derivative of the exponent is 2. So it ends up being 2e to the 2x. So often the notation here for f of x equal to e to the x, the derivative f prime of x is equal to e to the x, and then bracket x d by dx, and what that indicates is you should take the derivative of the exponent, all right, that d by dx notation. So there we go. So that clarifies yesterday. So what we want to look at today is derivative of natural log. So we're starting with functions that deal with e. So you know the derivative of the natural base. So let's move to log of the natural log. In order to do this, what we're going to do is we're going to use your understanding of logarithms, and we're going to convert this to exponential form. So this is going to be x equals e to the exponent y. So we're just using the properties of exponentials, or the relationship between exponentials and logarithms. We're going to take the derivative of both sides. So we're going to use implicit differentiation with respect to x. So the derivative of x is 1. The derivative of e to the y is itself, and then the derivative of the exponent would be derivative of y is 1, and then I need to indicate that I took that derivative, dy by dx. Clearing it up, I have 1 equals e to the y dy by dx. Simplifying it, the derivative dy by dx is equal to 1 over e to the y. Now, what is y equal to? So I'm looking at this exponent right here. What's y equal to? Up in the original starting point, we said y is equal to ln x. So we're going to replace that. So e to the exponent ln x. So y is equal to ln x. And we talked about properties of logarithms. This particular value here, the e, the opposite would be taking the log of it, so it undoes each other. It's an inverse operation. So you end up with 1 over x. So therefore, the derivative, if f of x is equal to ln x, the derivative f prime of x is equal to 1 over x multiplied by the derivative of what's inside the argument. All right, and we'll see, I'll do a couple of examples so you can see what's involved there. All right, so there is your derivative of a natural log. So all of this allows us to head towards, helps us head towards dealing with derivatives of functions that don't have base e. So for example, how do we, and this was the original question from the previous day, what is the derivative of an exponential function? Y equals b to the x. So to take that derivative, we're going to do a little bit of sleight of hand, if you would, or math sleight of hand. We're going to rewrite our base as e ln b. All right, that e and ln are inverse operations, so they undo each other, so you'd be left with b. So all we're doing is we're rewriting b using terminology that we already know. So the exponent now is going to be x ln b. All right. Now, when you look at this, b is just the base, so ln b is just a constant. It's just a number. It's just a constant. So ln b, because b is a number, it's a value of our base, it's just a number, so we can write it out front using our rules for logarithms. So, oops, sorry, I shouldn't say that. I'm not going to write it out front. Y equals, so let's take the derivative of this now. Getting ahead of myself. When you take the derivative of the function. So the function is a natural logarithm, a natural base function. So that means it's itself e x ln b multiplied by the derivative of the exponent. Now ln b is just a number, so it's just the derivative of x, and it turns out to be ln b. Okay, so there is our derivative. Now let's clean this up a little bit. So with that term inside the bracket, or with the e function here, I'm going to rewrite it as e to the exponent ln b, and put it in brackets. I'm going to move the x out. So I'm undoing the power of power rules with exponents here. And then we have ln b. Once I do that, we see that this e ln b, these are inverse functions, they actually undo each other, which leaves you with just the b value. So we end up with b to the exponent x ln b. And there's your derivative when dealing with an exponential. So therefore, if you have any exponential function, b to the x, then the derivative y prime will equal the original exponential function multiplied by the ln of the base multiplied by the derivative of the exponent. So that is the rule for taking the derivative of an exponential function. So it's itself again. So here's the original function. The derivative is the original exponential expression. Always ln of the base, and then take the derivative of the exponent. And it's all being multiplied together. And moving on, dealing with logarithms then. Finally, this gets everything covered for us. We have exponentials taken care of, and this will be the last one. So in exponential form, so we're going to convert it. Exponential form. So rewriting it, it would be b to the exponent y equals x. And then from there, we are going to do implicit differentiation because we know how to take the derivative of b to the y. The derivative of b to the y is the original function multiplied by, I'm going to use brackets here, ln of the base multiplied by the derivative of the exponents. The derivative of y is 1, and I took the derivative of y with respect to x. On the other side, derivative of x is just 1. So cleaning this up a little bit, we just have ln b multiplying b to the exponent y, dy by dx equals 1. And to solve for dy by dx, which is our ultimate goal here, it's equal to 1 over b to the y multiplied by ln b. So I'm just rearranging it. All right, now what is y equal to? So we're back to the same trick we pulled before. In my answer I have a y, and I know looking way back to the beginning, y is equal to log base b of x. So now I'm going to do that substitution here. So we get 1 over b to the exponent log base b of x ln of b. Inverse operations, okay, here we have an exponential to a log with the same base, so inverse operations would remove that, and you end up with 1 over x ln b as your answer. So therefore, if your function looks like this, It's an exponential, or sorry, logarithmic. Then the derivative would be 1 over whatever's inside the logarithm, so the x value, multiplied by ln of the base, and then it's now multiplied by the derivative of the exponent. And once you see a couple of examples, it makes it seem that much more clear. So I think what I'll do at this point, I'm just going to move and leave the examples for the next video and clean this second last video up.